Okay, the Bluetooth radio interface. I believe we get the door. Thanks. Okay, for one thing, the frequency ranges Bluetooth operates at 2.4 gigahertz, called the ISM band. Anybody remember what the significance is of the ISM band? It's unlicensed, anyone can use it for anything. So the organizing principle of Bluetooth is what's called frequency hopping. Spread spectrum. So that's conceptually simple to think about. We haven't spoken about that kind of multiple access yet, but basically what's going on is that the Bluetooth signal occupies a certain bandwidth, which is a little less than 1 megahertz. What Bluetooth will do is randomly change the 1 megahertz interval within the ISM band that it's using. So it's always randomly jumping around in frequency. So what we have is that in the ISM band, we divide that into 79 what are called hop carriers. Each with 1 megahertz of bandwidth. And then we randomly hop from hop carrier to hop carrier at a rate of 1,600 hops per second. So if you take the reciprocal of that, it is 625 microseconds per slot. So in other words, what's going on, let's actually draw this in a figure. So let's do this in 2 dimensions. This is frequency, and this is time. This is figure 3. So frequency is divided into chunks of 1 megahertz. And so on. Up to 79. Time is divided into chunks of 625 microseconds. So each of these guys, 1 megahertz. Each of these guys, 625 microseconds. So what's going to happen with the signal? In each time, I will occupy exactly 1 of these hop carriers. The next time, I will pick a different one at random from the available ones. So let's say I jump from 4 up to 6. Then let's say I jump down to 2. Actually, let's say I jump down to 1. Then I jump up to 79. Then I jump down to 5, and so on and so forth. So at any given time, I'm only occupying 1 megahertz of bandwidth, but the particular bandwidth that I'm occupying jumps randomly from time instant to time instant. Can anybody think of a good reason why I'd want to do that? So yeah, what you said was the first, you said first, you never run into somebody. So if someone else is out there using Bluetooth, and in a completely different piconet, what do they do? Well, they have a different random selection. So they will be picking these frequencies at random as well.
So if you're picking at random, there's always the possibility that, or is it that big that it's just negligible?
No, it's actually, in fact, okay, there are 79 hop carriers, so if I'm out there, what's the chance that someone else is interfering with me?
1 in 79
1 in 79.
622.
That's right. So in each time instant, if there's two people using Bluetooth at the same time, roughly 1 out of 79 time instants they're going to collide. However, the ISM band is great because it's unlicensed, but the trade-off for that is that you have to be able to put up with interference. So Bluetooth uses CRC checks and things of that nature to ensure that, for instance, if two users occupy the same frequency at the same time, the assumption is that information is lost. So there must be a mechanism to retransmit that information. In fact, that exists within Bluetooth. There's another reason to do this, and it doesn't necessarily have to do with other people using Bluetooth. Question over here.
I was just going to answer that question about
Yes.
fading and things.
Fading,
Since you're
excellent.
switching frequencies so much.
That's excellent. So, as we saw in when we talked about the physical layer weeks ago, it could be that there's a particular frequency at which there's a deep fade. So if you happen to jump into that particular frequency, in frequency hop spreads breakdown, for one thing, you don't need to know where that frequency is, because if you jump into it, you just lose that. You lose that slot, and then you jump out of it, and you'll presumably be able to keep going. If you just happen to be tuned to that frequency, you're screwed. So that's a good way to avoid fading. Yeah, excellent answer. One other thing that I'm thinking of, sort of along the same lines. Yes.
You can't eavesdrop because you don't know what frequency someone's going to be in, so it's a bit of a security.
Okay, that's a good one. If it so happens that someone else is using a hacked Bluetooth device, though, that's not necessarily true, because it's not secure in the way that cryptography is secure, for example. So if someone knows your sequence, then they can eavesdrop. But if there's someone else out there using the ISM band, let's say, that's occupying these two channels, you don't necessarily need to know that they're occupying these two channels, because chances are you'll hop in and hop out. So it'll just be those hops where you drop into an interfering band, those will be lost, but everything else will continue to operate as normal.
So,
Question?
can I differentiate between when the packet was lost due to fading versus someone else using the packet?
In principle, you could. You should be able to, if you did some kind of sophisticated energy detection, you could do that. The idea here is it's a low complexity protocol, so I don't think they do that kind of processing with Bluetooth. I think all they do is look at the slot, run a CRC, and see if there's an error. And if there is an error, it doesn't matter the origin that slot is running.
So if I have a frequency in which my packet's always